All right, guys, lesson 2.3 is all about factoring quadratics, which is the factoring part. You're familiar with that term. Quadratics are polynomials that have an x squared in them. So they can look something like x squared minus 9. You've seen those in a previous video, but it could also be something like 3x squared plus 7x minus 3. As long as it has an x squared in it, we call that a quadratic. All right. Last year was all about working with linear functions or straight lines. This year is mostly about working with quadratic functions, meaning you're going to have an x squared in there. Now, what I want you to do to start off today, I think if you pause the video and take 5 minutes, I want you to read through this first box, read through the game of numbers instructions, and then I want you to practice that game with these sets of numbers, okay? Just take 5-10 minutes, pause the video, read the box, try those problems, and then come back to me when you're done. All right, welcome back. So hopefully you have some solutions to this game that you've been practicing, because the problems that we're going to do today, really all you have to do is the game that you just played. All you have to do is find numbers that multiply to equal something and add up to be something else. And that's how you're going to be solving the problems, because quadratics factor a little bit different. In the past, you've done factoring like we've talked about, where you did 9 over 15 and you factored that to be 3/5. You've also done things with like 3x cubed plus 4x squared, and you would factor out the greatest common factor. Well, quadratic functions, if your biggest x is an x squared, when you factor these, if they can be factored, they look a little bit different than what you're used to. So if I have something that says like x squared plus bx plus c, and b and c, those are just random numbers. If I have an x squared plus something x plus some other random number, doesn't matter what it is, if that is able to be factored, your answer looks a lot different than you're used to. Your answer is going to look like this. You're going to have 2 parentheses, and both of them are going to have an x, and then you're going to have something inside with that x, an n or an m. They're going to look like that. That's what your factored form looks like. And I know you're not used to doing that. You're used to factoring and just getting 2 numbers being multiplied together or factoring out a greatest common factor. But with quadratics, when you factor them, you get 2 polynomials being multiplied together. And you've never done that before. So here's how we're going to do it. We're going to play that numbers game. And here's what we're looking for. So look at this example right here. Factor x squared plus 4x minus 12. The way that we play this game is I'm looking for 2 numbers that multiply to be the negative 12 and add up to be the 4. And because this is a video and we're trying to go fast, I'm going to tell you what they are. They're 6 and negative 2. Those numbers get plugged right into this formula and you're done. That would be your answer, x plus 6 and x minus 2. And I want to show you why really quick. X plus 6, if I were to go the other direction, if I were to multiply these together, I do x times x, which gives me my x squared. And then I would do x times negative 2, which gives me negative 2x. Then I would do 6 times x, which gives me a positive 6x. And then I would do 6 times negative 2, which gives me negative 12. Now notice, I did the 6 times the negative 2 to get negative 12. Well, that's what we did in our little game, right? You looked for 2 numbers that multiplied to be negative 12. Now, if I take those same 2 numbers, look, they're right here in front of my x. And when I add them together, I get 4x, which is the other part of our game that we just played. We looked for 2 numbers that multiplied to be the negative 12 and added up to be 4x. That's the easiest way to do these problems. It's kind of like when we were doing greatest common factor and we were distributing backwards. Well, we're doing the same idea. You are given a quadratic equation and you want to go backwards and turn it into 2 parentheses being multiplied together. We're trying to undistribute, we're trying to unmultiply those parentheses together, and you'll see why we want to be able to do that in some later videos, but it's an important skill that you're going to need to do this year. So let's start with example number 1. X squared, and I'm right here on the video, x squared plus 3x plus 2. Now the way I organize this, because I lose track of things if I'm not careful, I do what they call the X method. And I usually will put whatever I'm trying to multiply to on the top. So the 2 I'd put on top, and the 3 I would put on the bottom. So I'm looking for 2 numbers that multiply to be 2 and add up to be 3. Now, it's the first example, so of course we're starting with something easy, right? 2 things that multiply to be 2, well, there's only one option, a 1 and a 2. Those multiply to be positive 2, and they add up to be positive 3. So I'm going to put a positive 1 and a positive 2, and those are what go in my parentheses, that x plus 1 and that x plus 2. I just rewrite the problem like this, and now I'm done. So those 2 right there are the same thing. Those 2 are equal to each other. One of them is just the factored form, all right? Now, number 2 is going to require a little bit more number sense than number 1. Number 2, I'm going to draw my x, and I'm looking for 2 numbers that multiply to be negative 15 and add up to be negative 2. Now, here's where the number sense comes in, because before I start picking numbers, if I look at the top, negative 15, that's 2 numbers being multiplied to equal a negative. Well, that only happens if I have a positive and a negative number. They both can't be positive. So I know that one of my numbers is going to be a positive number and one of them is going to be a negative number. Now that's going to help me when I start trying to add these together. Because if I didn't know that that was the case and I just started saying, well, 1 and 15, that multiplies to be 15, but those add up to be 16. Well, yes, but they have to multiply to be a negative 15. So one of those has to be a negative. 3 and 5, those also multiply to be 15, but one of them has to be negative. And there's a really easy way to figure out which one, because when I add them together, they're going to equal a negative number. And number sense tells me if 2 numbers get added together and the answer is a negative, that means the bigger number was my negative number. So my 15 would have been my negative. My 5 would have been my negative. Because when I add them together, my answer comes out being a negative number. So my big number has to be the negative. So 3 and 5, those work. My 3 would be the positive, and my 5 would be the negative. So my answer becomes x plus 3 and x minus 5. And if I wasn't sure, I could write this out and multiply them together. I could do x times x, and I could go through all of that and make sure that I end up back where I started. You're welcome to do that to check your work. I'm not going to take the time to do that on a video because that's a lot for you to sit through when I already know that they're correct. So you can double check your work that way. Number 3, x squared minus x, that's going to be, right, a 1x, and minus 20. So when I draw my x, my big X, I put the negative 20 on top and the negative 1 on the bottom. So back to my number sense. They multiply to be a negative. So I know that 1 is positive, 1 is negative. And when I add them together, I get a negative number. So my bigger number is going to be, whoops, I wrote that wrong. My bigger number is going to be my negative number, whatever my bigger number is. So if I start looking at what multiplies to be negative 20, so that would be 1 times negative 20. Those definitely don't add up to negative 1. 2 times negative 10, definitely not negative 1. 3 doesn't work. How about 4 times negative 5? Those multiply to be negative 20, and they add up to be negative 1. So negative 5, positive 4, x plus 4, x minus 5. All right, let's keep going. Number 4, x squared minus 8x plus 12. So I'm going to draw my big X. 12 goes on top. Negative 8 goes on the bottom. Now, this is new because they multiply to be a positive. So they can both be positive numbers. But they could also both be negative numbers because a negative times a negative is a positive. And this bottom, again, it tells me which is which. When I add them together, if I were to add two positives, I don't get a negative. That's impossible. 3 plus 5 cannot equal a negative number. But if I add together two negatives, then my answer becomes a negative. So I know that both of my numbers are going to be negative numbers. So let's start timesing to 12. 1 and 12, those add up to negative 13. Negative 2, negative 6, those add up to negative 8. And that's what we wanted, right? So negative 2 and negative 6. So my answer is x minus 2, x minus 6. Okay, number 4, big X, 24 on top, 11 on the bottom. They multiply to be a positive. So they're either both positives or both negatives, but they add up to be a positive 11. So they're going to both be positive numbers because they add up to be a positive. So 1 and 24, that doesn't add up to 11. 2 and 12, either does that. 3 and 8, those add up to be 11. So positive 3, positive 8, my answer becomes x plus 3, x plus 8. Okay, number 6. I'm going to erase a little bit of this just to give me some more room. Sorry about that. Big X, let's put negative 36 on top and a 5 on the bottom. So this time they multiply to be a negative. So 1 is a positive, 1 is a negative. And when I add them together, I get a positive 5. So that means my bigger number is the positive. So let's do negative 1 and positive 36. That doesn't add up. Negative 2 and a positive 18. That doesn't add up. How about negative 3 and a positive 12? That doesn't work. How about negative 4 and a positive 9? Those add together to be 5. So negative 4, positive 9, x minus 4, x plus 9 becomes my answer. Those are equal to each other. Cool. Number 7, big X, 99 goes on top. Oh no, scary, a great big number. They multiply to be a positive. So they're either both positive or both negative, but they add up to be negative 36. So they both have to be negative numbers. So 1 and 99, those definitely don't add up to be a negative 36. How about negative 3? Negative 3 and negative, what would that be, 33? Those add up to be negative 36. So my answer would be x minus 3 and x minus 33. And you could keep finding numbers that multiply, but once you find the one that works, I could do negative 9 and negative 11, but there's no point because I already know which one works. The rest is just extra work on your part. So number 8, big X, what multiplies to be negative 72 and adds up to be 14? So they multiply to a negative. So 1 is positive, 1 is negative, but they add up to be a positive. So the bigger number is the positive number. So 72, I've got what? Negative 1 and positive 72. That's not going to work. Negative 2 and positive 36. That's also not going to work. How about negative 3 and positive 24? That gets me to positive 21. I'm getting closer. How about negative 4 and 18? That gets me my 14. So negative 4, positive 18. So x minus 4 and x plus 18. Okay, now I know this number game is going to be hard for some of you to find the numbers that work, that multiply together. Just start listing everything that multiplies. I'll show you a couple tricks on Desmos and the calculator that can kind of help you find the numbers. It doesn't do it for you. It just helps you sort the numbers a little bit easier. So if you have access to one of those, I'll show you how to do that in the next class period.